Okay, this is the uniform and circular motion and centripetal acceleration video, the first one of this unit from Mr. Bell's pre-AP physics class. The objectives of the video is 1, I can calculate tangential velocity and centripetal acceleration, and 2, I can understand the forces acting upon should say, object in circular motion, uniform circular motion. So what is uniform circular motion? It is simply the motion of an object traveling in a constant speed in a circular path. And where the word uniform comes from is constant speed. You could say uniform speed. Like, if you wear uniforms, everyone's the same, which means the speed is never going to change as long as it's in uniform circular motion. So if you throw a frisbee, the moment it leaves your hand, that frisbee is going to spin at the same speed. If you have a vinyl on a record player, it's going to be spinning on the turntable with the exact same speed at a constant speed. Or if you remember your fun childhood, and this is either an object of terror or of great joy for you. But a lot of the examples that we talk about, we can go back to a merry-go-round on a playground, because that's a good example of uniform circular motion. So the first thing we have to talk about is tangential velocity. Okay, and where we get that word tangential from is from a tangent line, which from geometry, if you remember, at a circle, a line that touches at only one point, and we call that the point of tangency, is a tangent line. Okay, so when we look at maybe a kid that has like an airplane toy is swinging it in a circle, okay, the velocity is going to be changing at each point along the circle. Okay, and you can tell that the velocity, the direction that it is moving at this point, is tangent to the circle. So if we want to find that tangential velocity, how fast something is moving on the edge of a circle, we're going to use this equation. And that is Vt equals 2 pi times r divided by capital T. Okay? This is the tangential velocity, and it is in meters per second, just like normal velocity. Okay? Normal velocity is distance over time, and that's exactly what we're doing here. The distance traveled in this case is one whole circle, which is a circumference. So the distance traveled is 2 pi r, and r is the radius of that circle. And period is what we call capital T. Capital T is called the period, and it is the time it takes for one revolution. So the time it takes to completely move around the circle in seconds. So here's an example. Okay, the wheel, it says example twice, that's funny. The wheel of a car has a radius of 0.29 meters and is being rotated at 0.072 seconds per revolution on a tire balancing machine. Determine the speed in meters per second at which the outer edge of the wheel is moving. Okay, so let's look at our givens. Okay, they gave us a radius of 0.29 meters. Okay, when he says that the tire is being rotated at 0.072 seconds per revolution, that means one revolution, one go round for the whole wheel takes 0.072 seconds, which is what we call a period. Okay, so t equals 0.072. So if we want the speed, that means we want the tangential velocity on the outer edge. Okay, so our equation is that it's 2 pi r over t. We plug in our numbers, 2 pi times 0.29 divided by 0.072, and our tangential velocity is 25 meters per second, which means the outer edge of the wheel is moving 25 meters per second. Simple enough, right? So let's look at a conceptual question now, okay? So if I'm swinging a ball on a rope overhead, okay, maybe it's like a slingshot, okay, what's going to happen if I cut the cord? Right there, okay? Which of these paths do you think it will follow? A, B, C, or D? I'm going to give you a little bit of time to think about it. If you want to pause the video before I give you an answer, I'm stalling, okay? A, B, C, or D. Do you think it's going to go straight? Do you think it's going to curve a little bit or curve a lot? Okay, well, the correct answer is A. If you cut the cord, it will go straight at A. And why? Because it will continue in its velocity that it has, which is a tangential velocity. So it continues on straight and tangent to the circle if I cut the cord. So if you look at that, you should probably be able to tell that even though the speed is constant during the entirety of a circle, right? All of these have v's, okay? And if I cut the cord right here, the plane would continue on in a straight line, okay? The only reason it's staying in a circle is something has to be accelerating on it, because even though speed is constant, speed is not a vector. The velocity vector is always changing direction, here to here to here to here. So something has to be changing it, and a change in velocity always means there is an acceleration happening, okay? So that acceleration is going to be causing what we call centripetal force. So if you look at this little drawing, if you have a ball or an object that was moving in this like little, zigzaggy path, anytime that there's a change in direction, there has to be some force acting to pull it this way. Or if it's going this way, something has to pull it back up here in order to get the ball to move up here and back down and back up, right? So even though there could be a constant speed, a changing direction means there's a changing velocity, which means there has to be a sort of force or an acceleration, okay? So that's what we call centripetal force. Now, if I'm moving in a circle, that means that that centripetal force is always going to be pointing towards the middle, and so it's kind of center seeking. If it's on the edge over here, then the centripetal force is pointing over here towards the center. If it was over here, the centripetal force points towards the center, okay? So if force equals mass times acceleration, then really what is causing this is an acceleration. So what we call centripetal acceleration, the formula is the tangential velocity squared divided by the radius. Centripetal acceleration is what A stands for. Vt is tangential velocity, and radius is r, which is in meters. And so you get meters per second squared because you're dividing meters per second by meters. Yes. Okay, so then once we have found that, if we plugged this centripetal acceleration into our force equation, if we know mass, then we know the centripetal force. Okay, so let's look at an example of actually doing that. A race car driver drives through a circular track going 23 meters per second. The radius of the track is 30 meters. What is the acceleration on the car? And then if the car weighs 10 kilograms, what is the force? So let's look at our givens. They gave us that the radius is 30 meters. We know his tangential velocity, or at least the speed that he's going on the outer edge of the track, is 23 meters per second. We know that the mass is 10. And we want to know centripetal acceleration first, and then force. So centripetal acceleration is the velocity squared divided by the radius of the circle that he is traveling in. So that's 23 squared divided by 30, which gives us a centripetal acceleration of 17.6 meters per second squared. So now if we want to know the force acting on that car, we now know the acceleration, so we can easily calculate force. Mass is 10 kilograms, acceleration is 17.6, which means the force acting on the car by the road and the tires contacting the road would be 176 newtons. Okay, so here's another fun conceptual question. So we have three circles here. Each of them are moving at certain speeds, and they have different radiuses. And they want us to know, they want us to tell them which of the following of these represents the greatest centripetal force. Okay, so again, our equation for force is always mass times acceleration. But in this case, the acceleration is centripetal acceleration, so we can plug in v squared over r for acceleration. So really the force is mass times v squared over r. Okay, they didn't tell us anything about mass, so I'm going to assume that all three of these cases have the same mass. Okay, but they did tell us each of these have different v's and different r's. If you want the greatest centripetal force, that means you want a very big V, but since you're dividing by R, that means if you want a big force, you want a very small number to divide by. Like if you want to divide up money, you're not going to want to divide it by very many people. You want a very small number for R. So you're going to look for the circle that has the greatest velocity and the smallest radius. Okay? So this has the greatest radius, which means it's probably not going to be the greatest force. Okay? This one just has V and R. But this one has 2v, so it's twice as fast, and it has a half as big radius as even this one. So since this one has the biggest velocity and the smallest radius, it's going to give us our greatest centripetal force. So that is the end of this video. On Friday, we are going to work problems and then continue on. Good night and good luck.